So hi everyone. So again I come back, and today I will discuss one more interesting question, that is the F by 2 circuit with 50% duty cycle using deep flip flop. I think you have a better idea already how to make the F by 2 circuit if you follow my playlist of frequency divider properly. Okay, but sometimes the interviewer ask like that, the design the F by 2 circuit using the deep flip flop. This is very easy process. Okay, so just I am asking one thing to you. So do you know about the toggle mode? Toggle mode. I think you have already idea about that. Toggle means if you talk about the JK flip flop and T flip flop, in that if J is one and K is also one, okay, in that the flip flop behaves as a toggle mode. Toggle mode means it will be zero, then one, then zero, then one. The same meaning. Okay, in T flip flop also same. If T is equal to one, then the T flip flop behaves as a toggle mode, then 0, then 1, then 0, then 1, like that. So this is the concept of the toggle. I think you have already idea. Actually, you have already idea about the T flip flop and JK flip flop. Just same thing I will use here. The concept of the toggle mode. So here I am designing the Abadu circuit using the D flip flop. So this is very easy. So the equation of the D flip flop, I think you already know. The equation of the D flip flop, next state equation, means Q is equal to D. Okay, but here I will I will convert this D flip flop into the toggle mode. So the next state Q plus is equal to D, but D is connected to the Q bar. So Q plus is equal to, this is the Q complement. So this is the equation of the toggle mode. Okay. So this is the equation of the toggle mode. How? So by the help of the JK flip flop. So for JK flip flop, the next state equation is Q plus barabar J J Q complement plus K complement Q. Okay, here you can see J and K is equal to 1. So J and K is equal to 1. If we provide J is equal to 1, it will be Q same, plus if we put K is equal to 1, 1 complement 0, overall 0. So Q plus is equal to Q. Okay, Q bar. Okay, so we can see here. So this is the equation of the toggle mode. The toggle, actually toggle mode is only happen in case of the T flip flop and the JK flip flop. But if you want to convert any flip flop into the toggle mode, so for that you need to perform some operation. So this is the thing. Okay, so this is the complete circuit of F by 2 circuit with 50% duty cycle. That is the F by 2 circuit. How I am telling this thing? Okay, this is the it be it is act it act it acts as in the toggle mode by the help of this equation. Okay, see, here I am drawing one waveform, one clock. So actually my English is not too much good, but I think you will understand everything. Just focus on concept. So this is the clock. Okay, so this is the clock. So so this is the positive edge. So this is the positive edge trigger D flip flop. Okay, and this is the toggle mode equation. Okay, so toggle mode means, so it is acting as the positive edge. So this is the positive edge, this is the positive edge, this is the positive edge, this is the positive. So for one clock cycle it will be 0. Suppose I am starting initially 0. So I suppose I am starting initially 0. This is the 0. After one clock pulse, this 0 will go in the complement for 1, and this one will be copy here. And again in the next pulse, this one will be go here 0, and then this one then this 0 will be pass here, and same like that. Okay, so this is the firstly 0, then 1, then 0, then 1, then 0, then I think you have an idea about that. Okay, na, I already explained na, this thing. I am naming this is the q1. Okay, so the time period of this waveform is, see, so this time period is the t, So this is the complete, uh, yeah. So this is the teen and teen. So T ought is equal to 2 teen. Okay, this is the 2 teen. So T ought is equal to 2 teen. Okay. So output frequency is equal to F in by 2. Okay. So this is the thing. And if you calculate the percentage duty cycle, okay, percentage duty cycle is equal to on time and off time here is same. So 1 plus 1 by 1, that is the 1 by 2 into 50 because of that. So this is the teen and this is the teen. So teen by teen plus teen, I directly write 1 by 1 plus 1. So that is the, this is the 100% now. Okay. So this is the 50% duty cycle. Sometimes sometimes this kind of question also asked like that. Convert the design the Abatu circuit with 25% duty cycle, V with 75% duty cycle. I already explained in the first part. I think in the first part I already explained. This is the, so this is the very simple process. If you want to convert in the 25% duty cycle, no issue. Just so just use the one AND gate. Just use here the one AND gate. If you use AND gate, if we use here the AND gate, if we use AND gate, this complete waveform will convert into the C. So this is the one time period is there. Okay, this is the one time period. If here I am performing the end operation. If you perform the end of, if both the logic is one, then it will be one. Otherwise, it will be zero. So this one part, this part is also there, and this is the completely four part. Okay, so this part is zero. Actually, if we multiply zero and one, that is the 0, and this is also 0 0. So this is the 0, but in this part 1 and 1, so it will be logic 1 and then again it will be 0, and this is like that. Okay, so this is the so this waveform have a total four part, one, two, three, four. So for only one part it will be one, and remaining part it will be zero. If you calculate the duty cycle, so on time is one or off time is three time three. One plus one, that is the one by four multiplied by 100. That is the 25% duty cycle. No issue, you can easily convert. This is the very easy process. Okay, so now if you want to make the 75% duty cycle, this is also issue. So tell me, so just think about that and tell me, so what gate I should use so that it will convert into the 75% duty cycle. This is very easy. Actually I need to, it should be means three times on and one times 0. If we convert this waveform into the 3 times 1 and 1 times 0, then it will convert into the 75% duty cycle. Okay, see, just by the help of the OR gate, if we convert, if we use the OR gate, just and this thing I am using, if we use the OR gate, actually this is the AND gate, you already know, no? This is the AND gate. Okay. So, so don't tell like that. Here the circuit I'm making again DQ and Q bar. Okay. If you ask like that, sir, design the circuit, then okay. I'm writing the circuit also. Okay. This is the thing. Okay. So this is the F by 2 circuit with 50% duty cycle. Okay, na? But here I want to convert into the 25% duty cycle. This thing I already discussed. So here, here this clock and this waveform, actually this pencil is I'm using another pen. Okay, here I will use the AND gate. If you perform the AND operation, so this is the F by 2 with 25% duty cycle. So instead of AND gate, here I will use the OR gate. That thing I am telling. First in the same expression, here directly I am writing. Instead of the AND gate, so instead of the AND gate, if I use the OR gate, instead of, sorry, instead instead of AND gate, if we use the OR gate, then it will convert into the 75% duty cycle. So by the help of the waveform, you can draw easily. This is very easy. Okay, right now I'm only writing the circuit. Okay, I think you you can make easily. Okay, now this is the thing. This is the by 2 circuit. This is the clock, and this is the thing. So actually, I am making the video, all the video short. That's why uh, here directly I am drawing the circuit. Okay, yeah. If you tell me I am drawing waveform also. Okay, so this is the OR gate. So this is the F by 2 circuit with the 75% duty cycle. Okay, no issue. This is the end, not buffer. This is the NOT gate. Okay, now, yeah, this is the NOT gate. You should remember this is the NOT gate. Okay, now. So just here I will use the one. Here the one OR gate. OR gate means, so it will be, if any one of one, then logic will be one. So this is the sorry, this will be, I'm making the I'm making wave for. Okay, see. So this is one, and only this half, this part is zero, and this is also one, and this is also one. Okay, now, so 3 times 1 and only 1 times 0. So here the percentage duty cycle is, the 3 times is on, only 1 times is off, multiply by 100%. So this is the 4 4 25 is 75% duty cycle. This is the very simple. So this is the process. So here I design the F by 2 circuit with 50% duty cycle. Just I explain the toggle mode. Don't need to explain in front of interview about the toggle mode. If he asks to explain, then you should explain. Otherwise, so directly make this circuit, and this is the equation of the toggle mode, and can draw the waveform, and like that, and use and find the duty cycle 50%. If he asks like that, convert into the different duty cycle. So if we use the AND gate, if we use AND gate at the output, then it is the 25% duty cycle. Okay, and if interviewer asks like that, convert into the 75% duty cycle, then you should use the OR gate. Okay, so I think this video is very helpful to you. So I am explaining each and everything from from basic. I think you don't have any doubt. If you any doubt, just ask me in the comment section. Definitely I will give the reply. Okay, so thank you, and I will take another one session for the frequency divided by the fraction number. Okay, thank you everyone.